Hello and good afternoon, CTS267 Section 840 students for the Spring 2017 semester at Anne Arundel Community College. This is the CCNP TSHOOT course, and this afternoon's video tutorial is going to be the fourth and final tutorial in the TINC garbage disposal troubleshooting tickets that we've been working on here. So as you can see, they've left switch 4 over here, and we still have no access to switch 4, although we can access switch 3. And the topology, again, has remained pretty much solid all throughout these troubleshooting tickets. So let's go ahead, take a look at our scenario, and see what we're facing here. All right, so Donovan attended a networking workshop and learned that if he replaced VRRP with GLBP, uplinks in his network could be more evenly utilized. So after implementation, we're good on VLANs 33 and 44. It's VLAN 11 where we have the issue. So sometimes they have internet connectivity, other times they don't. So this definitely narrows it down, right? Again, I mean, we know that VRRP was running between router 1 and router 2 here for our first hop redundancy protocol. So now we can quickly, kind of like slice the topology in half even by looking at router 1 and router 2 and specifically taking a look at the configuration for GLBP for VLAN 11. So we've got permission to do an invasive test if needed. So, and let me see if the IP is, yes, 209.165.201.225. So let's dive in here. And PC1 is definitely in VLAN 11. Let's say show IP interface brief, show IP route, see what we have for our default gateway. All right, so the default gateway is 10.0.11.1, and that should be the virtual IP swinging between router 1 and router 2. So let's go ahead and say ping 10.0.11.1, and let's see what we get here. And we should have to ARP out. And we are getting nothing. So interesting. So we have the IP address. What if we do a trace to 10.0.11.1? We've got our IP address, and we've successfully been able to have that assigned via DHCP. And actually, I wanted to do, let's do Control-Shift-6, and we'll do numeric. That way we're not waiting around for that name resolution to take place. And we've got no connectivity to 10.0.11. Let's check out PC. Well, actually, PC1 is in VLAN 11. Now, we've got our DHCP address, but let's kind of walk up here and take a look at switch 1. And let's make sure, let's take a look at the show VLAN brief, show VLAN. And when we look at VLAN 11, we've got quite a few ports here in VLAN 11. Let's see if I say show run. Let's see here. We'll say show run. Whoops. Interface Ethernet. And what's the first one? We're probably Ethernet 02. Oops, sorry about that. A little typo. Ethernet 02. All right. So that is the switch port. Ethernet 03. What about a show IP interface brief? All right. So 0001, 02, and 03 are all up. In fact, those should be the only ports. If we look at our job aids here, whoops, on switch 1, 00, 01, 02, and 03. So we're good. So only the 4 ports that need to be up are up, and the port that we're plugged into is in VLAN 11. So 02 and 03 are both in VLAN 11. All right. So we're good up to the switch. Let's take a look at the MAC address table, and let's see, actually, if we come over here and let's kill this trace route. Let's pull this back. Show interface Ethernet 00. All right, so our burned in MAC is 2700, and we're looking at 2700 right here. So we are on the right VLAN, and we're Ethernet 02. So we look good here in the switch. Let's say show interface trunk. And VLAN 11 is forwarding through the trunk. We've got the 2 trunk ports listed here. So now what we're going to do is let's transition up here to router 1. And again, we kind of had an idea that that is where the issue is going to be, is either router 1 or router 2, or both router 1 and router 2. So we're logged in here. Let's say show run interface, and actually how about a show IP interface brief first. Show IP interface brief. And there we are. And you can see the physical IP is 10.0.11.2, and it's going to be Ethernet 10.11. So we're working with a subinterface here. So show run interface, whoops, let's see, Ethernet 10.11. All right, so there's our GLBP configuration. So the IP address looks good. Our incap.1q is there. We've got the GLBP statement for group 1, and there is our virtual IP. We've got the preamp load balancing weighted, and we've got authentication configured. Let's take a look at router 2 and see what's going on over here on router 2. So we'll go from user exec to privilege exec, CO, or 0, C1 SC0, and show IP interface brief. Let's see what we've got. And this physical address is 10.0.11.3, so we'll do a quick show run interface Ethernet 10.11. And let's see what we've got here. We've got the incap.1q11, the physical IP, and there is where we run into our first problem. Right? So it looks like we're using the same group, the same GLBP group number, and the authentication string looks the same. It is the same, but the big difference, as I roll back and forth and you can see, is we've got the wrong IP address here. So if I was to say show GLBP, whoops, show GLBP, and let's say detail, and here's the group 1 that we're looking at, and you can see that this virtual IP address is not the same as the virtual IP address that we have on router 1. And so again, just in looking at this, it's doubtful that the IP was supposed to be 11.11. So again, because you can see the other virtual IPs here, 22.1, probably 33.1. So it's probably supposed to be .1, and there's 33.1 right there. All right, so in order to resolve this, and this was kind of an easy one here, we'll go into global config, because again, they gave us some pretty good details. Show run interface Ethernet 10.11. I'm sorry, show run interface Ethernet 10.11. Get this in here. They gave us some pretty good idea that the problem had to do with GLBP because they were making changes to GLBP. So let's sort this out here. Interface Ethernet 10.11, and we're going to say GLBP 1 IP 10.0.11.1. And so then let's do a do show run on the interface. All right, so now that looks a little bit better. What about a do show GLBP? And I believe there's a brief, and that's what we're looking for here. So the output's a little busier, but when we take a look here at group 1, right, you see we have 2 forwarders. The priority is 90 on us. We're the standby. You can see standby router is the local router. The active router is 10.0.11.2. We know that that's router 1, and the IP address being used is this 10.0.11.1. Our state is standby, right? So we are the standby router because we have a lower GLBP priority than does router 1. So if I was to say show GLBP brief, you can see here it lists out the information that we're looking for, and the active router, right, is local. That's us. So in other words, router 1. All right, so now let's check PC1 out, because that was interesting that PC1 was literally unable to get to. And there we go. And this is shows us going to router 2. And so we're doing a weighted. Yeah, so we're doing a weighted distribution, show run interface, and actually we have it up here. Hold on one second. Load balancing is weighted, and what is our method over here? Do show run interface Ethernet 10.11. All right, and we are weighted. Okay, so that is why we're tracing over to router 2. All right, so can we get to the internet now? Let's see. So trace 209, 165, 201, 225. And I forgot numeric again. Let's get numeric in there. And actually, it looks like it worked out perfectly for us there. All right, so let's take a look at the next ticket. So again, it was GLBP was the problem. They were pretty clear on that. And it was narrowed us down to VLAN 11, which was nice. And so PC 1 and 2 definitely have connectivity. So we're good to go there. So Donovan reports that PC 4 sometimes loses IP connectivity. He tells you that renewing the IP address usually helps solve this issue. So let's check into that. So we'll start with our verification that PC 4 is the problem here. Or I'm sorry, that PC 4 is having some problems here. So show IP interface brief. And so we are picking up the IP address of 10.0.44.11. Let's see if we've got 209.165.201.225. And forgot the numeric again. I keep forgetting numeric. Do a quick Control-Shift-6. There we go. Let's pull that command back up. All right, trace to 209.165.201.225 numeric. Kind of shorten things up a little bit here. All right, so it looks like we've got no issues with connectivity here. But let's be sure. What did that say again? This can't be can't be two activities in a row where there's no issue. So reports that PC 4 sometimes loses. He tells you that renewing the IP usually solves the problem. So let's do, let's do this. So show IP interface brief. And so we've got an address. Let's do this. Let's go into global config, interface Ethernet 00. Let's shut the interface down because we're using DHCP to get the IP address. So the IP address DHCP statement do show run interface Ethernet 00 should be there. So there's our IP address DHCP statement. So that looks good. So now let's bring the interface back up and let's see what happens here. All right, the interface is up. And so this is interesting. So now we get 10.0.44.129, which is well outside, well, it's well into the range of the 10.0.20 or 10.0.44. So let me shut it down again, and let's see if we get another address. See what happens here. And the DHCP address is either router 1 or router 2, probably. And so now we get a 10.0.44.130. So let's check. Maybe they split the DHCP range between them. So let's say show IP DHCP binding. And we don't have anything here. Show run section DHCP. All right, so this is interesting. So here's a DHCP statement for the pool. And what is the default route? Do show IP route. What's the default route now? All right, so the default route is still the same, even though I got a 10.0.44. But we jumped quite a bit into that range. Is router 2 configured for anything like that? Do show IP DHCP binding. And there is an address being assigned here. Do show run section DHCP. And here's the pool 44. So 10.0.44.1. So 1 and 2. So the DHCP is set up on both R1 and R2 for VLAN 44. So what is the issue here? Oops, sorry, on PC 4. What is the problem? Because it's getting the right address here. Or it's getting a address in the 10.0.44. So let's see what the issue might be here. All right. Let's shut the interface down. Let's bring the interface up one more time. And let's see what address that we get, because we are getting a... Aha! Okay. So there it is. So now we're picking up a 10.0.06, and that is definitely not going to work. So do show IP interface brief. So 10.0.0.6, clearly not in VLAN 44. Let me see here. We go into what? Switch 3? Let's take a look at switch 3 here and see what switch 3 sees. Show VLAN brief. And yeah, VLAN 44, that's definitely us. Show run interface Ethernet 00. Whoops. Okay, and so what VLAN or what port are we in here in the job aids? Let's take a look. Hopefully this documentation's correct. So we're Ethernet 02, it looks like. So let's take a look at that. Show run interface Ethernet 02. And that looks good. Show MAC address table. Ethernet 02 shows 2Baker00. Let's make sure that's the PC. And we were getting an address earlier. Do show interface Ethernet 00. And that is definitely us, 2Baker00. And oh, sorry, there'll be no entry for the ARP there. Let's check router 2 for that. Do show IP ARP. And 10.44, 10.0.0. So it doesn't show anything for 10.0.0. And here are the 44s. 1, 2, and 3. We know those go to the routers. And then here's that 10.44.11 that was to 2Baker00 out Ethernet 1, 2. So this was the address that we had initially been assigned. And so there's still a MAC address table entry for that IP here. So let's try PC. Let's see what happens. Let's shut it down. And we'll say no shut here. And let's see what happens. We get 10.0.44.14. So we're definitely getting a 10.44, but we got a 10.0.0.6. So there's got to be somebody else doing DHCP activities. And if it's not shown here, we don't have access to switch 4. So let's, on 3, if I say show interface trunk, and let's say show CDP neighbor. All right, router 1 and router 2 pop up in the show CDP neighbor. We've got the trunk link, and VLANs 1 and 44 go across that trunk link. All right, so this gets interesting because I don't see. So when we had the rogue OSPF router or node, so Ethernet 0001 and 02. And then 20 and 21. So on switch 3, let's take a look at the MAC address table here. So it's got all these MACs in that VLAN 44. So 01, 0001, 02, so we're good there. And then 20 AABBCC 44. And that is the 20 that goes across that's one of the member links in show run interface Ethernet 20. Yeah, that's inside this Ether channel. But that is typically not the switch MAC address, so it's possible. Obviously, we can't shut the port channel down between these two guys here. So if we've got a rogue DHCP server hanging somewhere over here, what we would want to do is DHCP Snooping. So we can't get on 4, so that's okay. So let's do this. So let's get into global config. And we're going to say IP DHCP Snooping. And we need that command by itself. And then IP DHCP Snooping VLAN 44. Now, once we do this, if I were to say do show IP DHCP Snooping, right, Option 82 on untrusted ports is not allowed. So there's no option 82 there on the untrusted ports. So we don't have anybody in here. So everybody is untrusted right now. So we want to trust the ports facing the DHCP server for VLAN 44, which is going to be, this is where it'd be nice to have these printed up in front of me here. So Ethernet 00 and 01, 0001, 0001. So if we did it across the board, so let's do this. IP, oops, sorry. So interface range Ethernet 00 to 01, and we would say IP DHCP snooping trust. So again, we're facing the, or I'm sorry, we're enabling trusted interface status on the two interfaces that face the DHCP servers, which the legitimate DHCP servers, which are router 1 and router 2. So we would want to do this for the other VLANs as well. But now what I want to see is do show IP DHCP snooping. All right. So at this point, the only two trusted ports are Ethernet 00 and 01, which means if we've got DHCP server originated messages, right? Like DORA, the discover, offer, request, act. So if we've got an offer or an acknowledgement coming through, it should only be allowed to come through 00 and 01 on switch 3, because all the other ports are at this point considered to be untrusted, right? So another best practice of what we would do is what port is Ethernet, whatever port the server is on. So whatever port the server resides on, we would want to limit the, what is that, Ethernet 02, 0203, okay, so 02. So we would want to do a DHCP rate limit as well. So interface Ethernet 02, IP DHCP, is it rate limit or limit rate? It's IP DHCP, oh, snooping, sorry. And it's limit, there we go. Limit rate, and we'll say that we'll allow 15 DHCP packets per second, right? So we would want to rate limit the host-facing port, and we already have the trust setup going northbound. So do show IP DHCP snooping, and that's what that would look like, right? So that's what our DHCP snooping is going to look like. In fact, show IP DHCP snooping and binding VLAN 44. Sorry about that. I didn't want the binding. I wanted, let's see if we have any statistics. All right, so now let's get on to router 4, and let's do this. We'll shut that interface down, and we're going to bring that interface back up in the hopes that we can smoke out that rogue DHCP server. Because if we get packets, DHCP server originated packets coming through a link that's not trusted, so you can see we ended up with a legitimate address here, right? So that looks good. So show IP interface brief. So we're good. Show IP route. We should have 10.0.1.44.1. Can I trace with numeric out to 209.165.201.225 with the numeric? All right, and everything looks good there. And we didn't get that bogus address. So if I come back to switch 3 here, show IP DHCP snooping. All right, it's enabled on VLAN 44. Option 82 is enabled, so we're trusting the upbound ports. Verification field, get address field. All right, so that's how we're set up. Let me see, because I could have sworn, I'm drawing a blank now on, I don't see anything in the log. And what I'm looking for right now is I thought that we would see something if we had a bogus DHCP server out there, have it coming back. And so again, if we did it here on on switch 2 for VLAN 33 and for switch 1 for VLAN 11. So again, if we did it on switch 1 one more time, oops, sorry, let's get into global or privilege exec in the global config. So IP DHCP snooping, IP DHCP snooping VLAN 11. Whoops, not 111, VLAN 11. Let's pull that out. And then we'd go into the two uplink ports, interface range, FA, Ethernet, or not FA, sorry, Ethernet 00 to 01, IP DHCP snooping trust, and the host facing port, which was Ethernet 03, we would say IP DHCP snooping limit rate, and we'll do 15 packets, DHCP packets per second. And that should be enough if we were to come over to PC2, show IP interface brief, and global config and interface Ethernet 00. Shut that interface down. All right, and we'll wait for our message here, and then we'll say no shut. Bring it back up, and we should be able to get an address without any issues. 13, that works. Do show IP interface brief. Do show IP route. And there is the default gateway right there, the 10.0.11.1, so we're good there. And do trace 209.165.201.225. And I forgot the numeric again. Boy, I forget the numeric all the time. And there we go. So we've got connectivity. So that has got to be what they were looking for. And I'm going to look at the hint here real quick to see if, all right, VLAN 11. So Donovan's PC connected to driver. Renew the IP a couple of times, replicate the issue. When you discover and solve the issue, make sure it does not happen again in the network. It had to be a rogue DHCP server. All right, so let's take a look at this final ticket. And it is Donovan's PC, PC4, should be able to use SSH to connect to layer 3 devices. But for some reason, Donovan can't connect to gateway 2. And this is off of PC4. And we were just working with PC4 here. So let's take a look. Show IP interface brief. Right? Show IP route. The default gateway is good. And that's the address that we're using. So we can't get to gateway 2. Let's come up here to gateway 2. Now, if we're trying to SSH, we had an earlier issue that we can use to our advantage here. Right? So let's, right out of the gate, show IP SSH. Right? Because we know it's something with SSH. You can see it's not the version number, right? And we've got a key has been created of 1024 bits. All right, so that looks good. Let's say show, run, and begin line con. All right, so we've got an access list. And typically, if you're having issues SSHing into something, it's the earlier issue we saw, or we've got an ACL. But let's confirm. Let's get the IP address here real quick. The gateway 2 IP is 10.0.1.11. And so let's confirm that this is in fact a legitimate issue. Admin to 10.0.1.11. Let's see what happens. Give it a couple seconds here. All right, connection refused by remote host. So definitely a problem. So it's probably related to this access list. So let's say show IP, or just show access list, and see what we've got here. So 22 inbound, transport input SSH is good. So 22 inbound, and what does 22 inbound say? Permit 10.0.33.0 with a /24 wildcard mask. So this should jump out immediately at us that it's 10.0.33 when it should be 10.0.44. Now, this other ACL up here, access list 2, would allow everything out of the 10 network, but what was the requirement? Did they say Donovan's PC, PC4, and only PC4? Okay, so the bait here on this ticket is, oh, well, I'll just use access list 2, but that's going to give access to every PC in the 10.0.0.0/8 network, so all PCs. So it's only PC4. So a couple ways we could approach this, right? We could create a net new ACL. So let's do that. Give us a little something to do here. So we're going to say IP access list standard, and I'm going to call it, let's say VLAN 44, right? So permit 10.0.44.0.0.0.255 for our /24 or net mask of 255.255.255.0, and let's log that. In fact, I could have put a cookie here, which is nothing more than a description just saying Donovan's PC or VLAN. Actually, is it Donovan's PC or VLAN 44? And I apologize. And only PC4. Well, only PC4 is in VLAN 44. But if it was only PC4, which is getting its address via DHCP, we would have to leave it open for the entire /24. So let's get into line VTY 0 through 4. No access class 22N. Whoops. No access class 22N. And we're going to say access class, and what did we call it? So here's where we would put our name. We just said VLAN 44 inbound, right? So do show run begin line con. All right, so now we've got our new VLAN or our new ACL in there. So let's come over to PC4 and let's try this again and see if we're able to connect to Gateway 2. And if we get further than our connection refused by remote host, outstanding, CISC0, and we are on Gateway 2. All right, that last one was definitely among the realm of the easier tickets to troubleshoot because clearly they tell us we can't connect via SSH, so we know we should immediately go look at Gateway 2, look at the VTY lines, check out the SSH configuration, and then there's our answer. All right, well, this is going to wrap up the tutorial and solution set for the last TINC garbage disposal company trouble ticket scenarios in challenge number 7. All right, enjoy, and I will see you all on Thursday.